Hello, everyone, and welcome to another session of MLOps Coffee Sessions. I'm Vishnu, and I'm here with Dimitrios, the local legend of the MLOps community. And today we have a great episode planned for you guys with Srivatsan from the AIEngineering channel on YouTube. You guys will definitely have seen his work on LinkedIn, on YouTube. He's an extremely prolific content creator around machine learning, engineering, MLOps, has created an incredible amount of content and is a wealth of knowledge that we're excited to explore with him. Thank you so much for joining our podcast today, Sri.
Thank you, Vishnu, for the introduction. Nice introduction. And thank you, Dimitrios. You guys have been doing an amazing job, creating content on MLOps, right? Which is pretty rare because most of the time we see a lot of content on machine learning, model building, algorithms and all. And you have been bridging that gap, taking this machine learning to production. You guys have been doing some amazing jobs, and thank you for having me today.
Yeah, I want to second that, just throw it right back at you. It feels like you are also doing that hard work of trying to bridge the gap and show people, yeah, there is this model building part, but also there's this other part that's pretty important, which is the whole MLOps piece. And you even get into, I know that you're doing courses on Kubernetes on your channel. And so maybe it would be good to start with a bit of background on how you started this YouTube channel and what inspired you to start talking about these subjects.
Yeah, so I think the YouTube channel is here and off hold. When I started this channel, I was finding plenty of content and courses on building ML models and everything, right? But not really that talks about the engineering aspect of it. If you take from my experience, the algorithm part and everything is very important, but it constitutes only like 20% of the actual entire machine learning work, right? You have data collection, you have model deployment, you have model monitoring, you have to build the pipeline, feature engineering, feature store. There are a lot of aspects that come into play, the data engineering aspect. So while there were plenty of YouTube channel covering the aspect of algorithms and other aspect of it, my focus was more on taking it to the next level and connect the academics to more like industry. Right, that's how I started this channel, and the very first thing I launched was ML engineering, more talking about the nuances around data collection, data engineering, some part of ML, model monitoring and all, and that's how it has evolved. And over the time, it has been more focused on engineering ML systems rather than purely ML modeling.
I love that. I love that description of engineering ML systems. I think that is the main challenge most companies face nowadays is how do you not just build a model, how do you construct the whole system around it? And then how do you introduce the level of quality and monitoring and everything that's so essential to put something into production? Yeah, so if you were telling somebody that were to join the MLOps community now, or were a machine learning engineer that was starting to get into production, how would you tell them to go about learning MLOps and how to start with the field?
Got it. So when we talk about MLOps, right? MLOps is pretty broad subject, and there is a huge effort that is involved in building an MLOps capability in an organization. It is not just like fitting some external tools or products. It's also like bringing in a cultural change within an organization when we talk about MLOps, right? And MLOps has too many components. Like once your model is developed, you need to continuously integrate the model and deploy it in production because your model will keep changing. The data will keep drifting, your model will keep drifting. You need to have that pipeline set up. That is one aspect of it. The second aspect of it, you are bringing up the infrastructural component to it. How do you enable continuous training? Because once your model gets drifted, you need to trigger off the pipeline and continuously train your models, right? And finally, how will you continuously train? That's where the continuous monitoring comes into play. So you need to know like whether your model has drifted with your ground truth and you keep monitoring it. And building all this component with your within your AI ML capability is very time consuming. It can take years to get that built. So what I would say is start and identify your key problem area, right? One of the couple of examples that I can give is where is your real bottleneck? your data scientist team might be good, but handing over your data science artifacts to the software engineer might take time, and the deployment process can take again months. So if that is the challenge, then start building your continuous integration and deployment pipeline, right? More on the model deployment aspect of it. The other challenge typically we see in organizations is in the data itself. Right now, if you take an centralized capability of models like an cyber intelligence team or cyber security team, they may be doing multiple hypotheses, building multiple models, and then seeing like which works better for the data. Right? When there are multiple teams involved, everybody has to go and build the data pipeline and then start training the model. And what happens, like you end up like kind of a spaghetti data pipeline in that case. And that's where maybe focus more on feature store. Try to centralize your base metrics and the aggregated metrics on the feature store, and then maybe give that to your centralized team. So I would say, like when you're starting on MLOps in your organization, focus on your key challenges, and then that would drive your capability that you need to implement.
Yeah, that makes perfect sense. I think I love that word capability that you just used, because machine learning has to be a capability of the company, not merely sort of window dressing, not merely something we say because it sounds, intelligent. And in order for it to be a real capability, it has to address a core need. One of the questions that I have listening to the answer that you just gave was about continuous integration and continuous deployment. This is a concept that I think a lot of ML engineers and data scientists get exposed to quickly, but maybe never really wrap their heads around, okay, how does CI/CD look in the software development paradigm, and how does it look in the ML paradigm, and when should we do it? How do we do it? Sort of a similar question. If an ML engineer were to ask you, okay, I heard your advice, I've thought about my company's need, we're building a model to the right thing, and the data science team is working on that, but I want to get started with CI/CD. How should I go about it? What would you say to them?
Right. Now when we talk about a machine learning project, right, it's not only an ML engineer. Typically, it's about a data engineer, ML engineer, and a IT software engineer team. Right. So they work hand in hand. Now the key difference is MLOps is nothing but ML plus DevOps. Right. Now the DevOps concepts are pretty similar, but there is an additional element of artifacts that come into play, like ML models or ML model distribution that we capture with the data, whether we use for monitoring, and those aspects of it. So if somebody is starting for an ML engineer, it's good to know DevOps. It's and this DevOps also varies by environment. If you're on cloud, every cloud has a different way of doing DevOps or MLOps, right? If you're on-premise, you may have a typical Jenkins pipeline or other pipeline that creates the artifacts and deploys it. So that also varies. So when you're kind of an ML engineer and trying to get into MLOps, I would say start with DevOps. Learn based on the platform that you're trying to implement it. Work with your software engineers. See how you can basically provide the ML artifacts to the software engineer as well, because it's not only your typical application, your typical ML application. Once it is experimented and built, it becomes a typical software project, right? It is not. There's no more experimentation. It's just a software artifacts that you deploy. So that's where you get into basically see how you can pass the ML artifacts, like your ML model, the data distribution, and everything to your software engineer that can be deployed. So start with DevOps and see what additional capability you require for the machine learning aspect of it.
Yeah, that makes a lot of sense. I think I have this question a lot personally around DevOps. And as you mentioned, each cloud provider has their own sort of paradigm, philosophy for working on DevOps, they have their own toolkit. You also mentioned the on-prem. Honestly, it's pretty overwhelming, because as an ML engineer, I need to know good software engineering practices. I need to test. I need to do all these things. I need to know algorithms, data structures. I need to know machine learning. I need to know, a little bit of this DevOps stuff now too. How should machine learning engineers approach the DevOps world without getting too dependent on one framework or one sort of cloud provider? How can we still stay general and applicable in other environments?
So Vishnu, that's a nice question, right? And that's a challenge that we have been dealing with, because many AI leaders does not understand that building ML model requires a team, not an ML engineer alone, right? Because if you start overwhelming your ML engineer, they will be clueless whether to concentrate on the model, concentrate on the ROI, or concentrate on the software engineering aspect of it, right? Yeah, the full stack data scientist, whatever we hear is kind of a myth. You will never find that full stack data engineer. Even if you find, your insights can never be productionized, because is already, the experimentation is a pretty cumbersome process, right? Getting your model to 75% accuracy, 80% accuracy, every auto ML will do. And after that, each iteration takes kind of a lengthy process. It can take months. So what I would say, from an organization, you always have multiple team with their own responsibility. But from an MLOps engineer, coming to your question, right? If they want to learn DevOps, I would say like focus on the core concepts of it. The concepts are similar, whether you use like Google Cloud Build or Google Cloud Commit or Amazon Cloud Commit or Cloud Pipeline, or on-prem Jenkins and all. The core concepts are same. How your artifacts are going to be, it's going to be either a GitHub or Bitbucket or any Git compliant repository in any cloud environment, right? That's not going to change. Now, how you take that, how you build your artifacts, that will be different, but that's just a tooling issue. You can learn the tool in a day or two. All the cloud provider tools are pretty easy to learn. You just need to know how to create the descriptor to run it. And the real challenge comes in the YAML file or the Terraform file, what we write, right? That's where the real challenge comes in. It's over the time we can learn that, but the core concepts remain the same. It's not going to change, right?
Yeah, that makes perfect sense.
Right.
Yeah, so continuous deployment, continuous integration, as you said, the concepts are what matter most, and I totally see what you're saying there. One of the questions I have for you next is testing in machine learning systems. Right now I'm trying to work on an end-to-end machine learning system at my company, and the challenge I find hardest to figure out is how to set up a coherent framework for testing, and wrap my head around it. What advice would you have to a machine learning engineer or a machine learning team that's trying to think, hey, how do I test a system robustly?
And when you talk about testing, right, there are multiple testing, right? One is you have the final model artifact, because I'm going to leave, because it's an MLOps show, right? I'm going to leave the model evaluation part of it and model testing part of it. I'm going to focus on MLOps side of it, right? So when we talk about testing, you have the performance testing. The reason is, as well as your data testing, right? The performance testing, the reason is, say like you are running an credit card transaction business, and you want to you're a big bank, and the bank has millions of transactions. You want to make sure your model is serving within that SLA. That's where your scalability of model comes into play, whether you want to run on Kubernetes, auto scale and everything, right? So that is the first part, performance testing. Now, performance testing is relatively easy conceptually, but relatively hard. It's hard to implement. The reason is like you need to have your infrastructure sizing, your CPU sizing or GPU sizing, your RAM sizing, everything comes into play. How do you want to size your infrastructure comes into play? Because when you want to handle millions of transactions, you need to make sure your infrastructure is able to address that, right? So that is one part of it. Coming to data testing, this is key. The reason is your model can be useless as soon as you deploy it. The day you deploy it, typically what we do when we train our model, we don't have the labels, current label as soon as it's done. Let me go to the credit card example, right? If you go and swipe a credit card, you will not realize it's a fraud unless for next 30 days or 60 days, right? So you will get label after only 30 days or 60 days. So when you are developing a model in this case, your model is already 30 days, 60 days old data that you're working on, right? Or even more than that, because you need to keep some data for evaluation and everything, right? Now, when you put it in production, maybe the model is not like performing with the real world itself by itself, right? So the first is checking the model reliability testing. You make sure that what you get into the model is what the output score is similar to what you are seeing in your training. And that is pretty easy, because what you do is you take some sample record, you run some PyTest or something like that before you execute your CD pipeline, and then make sure the model is giving the right results. The second thing is testing your model with live data. Now, your incoming distribution and the real world distribution can be completely different. And that's where what you do is you frequently take the model metrics that the model is generating along with the baseline metrics and run some statistical tests like simple population stability index or KS test or something like that to see how different is both the distribution, and you keep a threshold over there. And in that case, if you see, okay, the thresholds are completely different, you kind of maybe go to a rules-based engine or start your continuous training pipeline, redeploy the model and all. So that's what I typically do with the testing part of it. And testing is continuous in when it comes to machine learning. It's not like software engineer where it's very deterministic. You pass A rule, you'll get B output, right? It's more probabilistic, and that's why the continuous testing comes into play.
Yeah, that framework that you offered around performance, model, data, it's something that makes a lot of intuitive sense. I think it's something that I've also seen, in the full stack deep learning course by Josh Tobin and Sergey Karyev. It's a really helpful toolkit for a practitioner like me to try and actually, apply testing. I think sometimes what I find the hard part to be is a lot of times we build machine learning systems according to particular assumptions, right? And those assumptions are highly customized to our context.
Yeah.
In our case, we're working with some image data, and we really expect this image data to have particular features, right? And how you write tests and how you engineer the features and everything with the tools right now, it doesn't necessarily feel as intuitive as writing a test suite in like PyTest or something like that. So I think that's something where I'm hopeful that maybe new tools or more sort of advice will come out that will help people like me do it better.
Right. And also if you see like the complex stuff like NLP and computer vision, right? The research has also not come to a level where really we can identify drift or explainability. There are multiple aspects that it has not matured to that level. If you take NLP, it's very difficult to find a drift on NLP data, right? So you need to still go with the model output and see the drift rather than going with the data itself. In that case, most of the time you'll be working with model drift, not the data drift. So the research side also has to mature for us, for the tools to implement it.
Yeah, that's a great point, actually, particularly on the NLP drift point. And I actually find it challenging sometimes to explain, to other stakeholders, like, we just don't know some of these things. For example, I read a great paper I probably mentioned on this podcast before about backwards compatibility in machine learning. It's a paper that Microsoft's MLOps group wrote. And what they basically showed is that, model iteration 1 can do well on data point 1 and classify it correctly. But model iteration 2, which has a higher overall aggregate accuracy score or whatever metric, ends up not performing well on data point 1. And if data point 1 is part of a sufficiently rare or expensive class, your model might look like it's doing better, but not necessarily have backwards compatibility. And these kinds of things, it's a very good point to make. It's a really important.
Well, I want to point out
that you want to catch.
One other piece that you were talking about and that you said. I'll let you jump in real fast, but this is a perfect quote. Your model can be useless the day you deploy it. I think that is brilliant, and we're probably going to make a little quote slide with you on that, because that sums it up in a nutshell.
Right, and it's very true, right? Because the way the concepts around us are changing is pretty drastic, right? Sometimes, like you take typically, like, let me go to the same credit card example, right? The fraudsters are innovating faster than the organization, the financial organization. They always find ways to do better fraud in a better way, rather, right? You take example
Exactly.
Earlier we had the magnetic card, and magnetic card, the fraudulent rate was pretty high. They moved into all this what do you call the EMV cards. But today, if you see, the fraudsters have moved online, and still the fraud rate is pretty higher in the industry. So as we get better, the fraudsters are getting better, and it's with any industry, any use cases. Very few use cases where the data is stale and it goes on forever. So that's where I said, like, most of the problems that I have dealt with, the model sometimes is completely different than what it was developed when we deploy it.
So one thing that you mentioned too before was this idea of trying to get something out as quick as possible and then realizing where your bottlenecks are. so that you can focus your time and your energy and your resources on those bottlenecks and fix them, hopefully, and move on to the next one, find the next bottleneck. And that feels like it's a trend that I've been seeing a lot of people talking about, how it's really important to just get something up and running end to end, and then try to start really bringing on more and more complexity as you get more familiar with where the problems are. Are there any other trends that you feel like you've been seeing within the MLOps space?
So the mostly the MLOps, if you see, right, and coming to your point, right, like one is the fail fast is a pretty common terminology, but I would say like fail smart, right? Fail fast, everybody can fail fast, but you need to really start failing smart, because ML machine learning is a huge investment. Even the POC is a huge investment. If you just put it as a throwaway stuff, then it's not going to help. You spend like thousands of dollars, right, in the higher thousands of dollars to build a POC, and that POC cannot be reused when you go to the real implementation. Then it's going to be a big push from the business stakeholders of not funding it further. So that's why I say like fail smart. And coming to your point, right, the MLOps space, as it's not yet completely matured. The organizations, if you really see, have not really got into MLOps in a big bang. They are still struggling with the ML side of it, and that's where the challenge comes in, because taking it to production is taking time. Now, some of the cloud providers are really doing a great job, especially AWS and Azure. Even though I am a Google fan, I use GCP a lot. They are lacking backward compared to AWS and Azure in MLOps. The tools are pretty friendly. They have pretty easy way for users to orchestrate the pipeline and deploy it. GCP is investing a lot on Qflow, but Qflow comes with its own engineering challenge, right? It's not data scientist friendly. It's an engineer friendly tool. That has to change. So the next part is the feature store is pretty important. And I see a lot of company. One thing I'm seeing my interaction with a lot of companies is they are investing a lot on building centralized feature store. While the data engineering part is always there, but now they know that there is a need for a model specific feature store where we have all the aggregated metrics. So data scientists need not worry about it. Let me pre-build it. You focus on experimentation. You focus, and this way you're reducing the cost as well. Think about it. For every experimentation, if I have to do the data engineering and then do the modeling, it's going to take time. But with having a feature store, you can just start experimenting and focus only on the model and not on the data.
Yeah, I think your analysis of the cloud providers is spot on. I have been very impressed with what I've seen come out of AWS in particular. That's the one I'm most familiar with. And I think I will say upfront, I work at a startup, and it has given us access to a lot of capacities that would have taken us a long time to develop. We're moving a lot faster because of it, and I'm a big fan of what they're doing. And the speed with which, in particular, the SageMaker team, I know they're expensive, but they are really pushing out new features very quickly and making my life a lot easier. One of the questions I have, and I saw you have a, sort of a playlist on this that I'd love to learn more about on your channel, is Auto ML. I feel like that is one of the most interesting products that GCP has. It's not one I've necessarily worked with a lot. I'd love to understand more, what's your perspective on what it is, how you think it might be used, and how you think it might set GCP apart. Or maybe not. I'm just curious.
Yeah. So GCP has a very good Auto ML capability. They have Auto ML almost in all the places, right? They have the Cloud Auto ML set of suites where Cloud Auto ML Vision and Cloud Auto ML NLP, and they have the BigQuery, right? Auto ML as well. They call it as Auto ML tables, and that is really an interesting product because you don't have you don't have to really move your data out of BigQuery into a Python notebook and start writing Python code. You can just write SQLs to build your model, the BigQuery ML and Auto ML tables as well. So what sets GCP apart is definitely the Auto ML set of functions. But if you take from real world data, right, the Auto ML tables alone might not provide you an end-to-end model. How I see the Auto ML is your basically baseline model, right? When I have my data, let me do my feature engineering. Let me feed it to the Auto ML and let it give me like which model, which hyperparameters work the better. And from there, what I can do is I can take that as my baseline model, and maybe I start working it and go back, tune the features, and then add it back to the pipeline, run the Auto ML. I keep iterating it. One aspect is Auto ML is very expensive. It's the reason is today Cloud Auto ML. If you go with Google Cloud, they don't allow you to take the model out and deploy by yourself. You have to go with that deployment, right? And that deployment is pretty expensive. If they give me the model, I can take it and deploy it on Kubernetes, my own cluster. I can keep the cost less. But the cost is also pretty high when we talk about cloud automation mission. But it's a good way to accelerate your hypothesis rather than running, okay, I have the data now, let me run XGBoost, let me run SVM, let me run XYZ, ABC. I just feed it to AutoML, it gives me a leaderboard, let me pick the top two and then iterate further.
No, that makes a lot of sense. I like that description of it being an easy baseline, and you can see how companies might achieve some level of team development efficiencies, because right now it is a bottleneck to hire. It feels like in any organization you have to hire across every function at 10x the speed that you need right now. Whether it's engineering or ML or whatever it might be, and this could help with that a lot.
Right. And that's what I keep telling you, right? Instead of having, if you need 2 data scientists or 3 data scientists, if you need 3 data scientists, one can be Auto ML, other 2 can be human. You cannot take out the human out of the equation, right? You still need them, but it can definitely reduce the number of data scientists that is required in a team.
Absolutely, yeah. Those efficiencies are crucial. I did want to dive further into one the point that you just mentioned around deployment. So deployment, I feel it's a pretty sort of loaded topic. There's a lot of tools that are out there. Each cloud provider has their own thing. Even something like AWS itself, I know that it has multiple options to deploy models internally. Then there are sort of like completely non-tool dependent ways. You can deploy it as like a Flask app or whatever else. What advice would you give to a team that's saying, okay, I have a model for my data science group, and now I need to think through deployment and what that looks like. How would you go about doing that?
It's not only the tools also, right? It's also the pattern, right? Now, when you deploy a model, it can be completely batch, right? We need not worry about it. I can just run a batch job and do it. If it can be real time, right? As and when the data is coming via API or streaming, I need to kind of invoke my model and then predict and send back. It can be edge. I want to deploy my model in an Android phone or any kind of IoT devices. So the pattern really changes. So what I have seen in my experience, right, when the deployment aspect comes into play, now Flask is a pretty common technology that is used across, which is pretty good when you don't have very low latency. When I say like if you have millisecond latency and all, you may want to maybe go to Kafka or handle like a lot of load. Maybe go for Kafka or some other streaming platform that can predict the model faster and send it across. Because when your payload is pretty higher, the Flask application might slow down because transferring the payload over REST API is going to take its own time, right? And this is not a huge time. It's still in the millisecond range. It can be from 10 milliseconds to 100 milliseconds. I have worked with some projects where if the model inference goes about 10 millisecond, then the model cuts off and they make a default decision because that's the business SLA, right? So the pattern matters. Now, how to kind of do and with all the tools, there are a lot of tools today. Every cloud has their own tool. If you take AWS, SageMaker has its own deployment tool. If you take Google Cloud, has Google AI prediction. I would say stick on to something which is common, right? And Kubernetes really comes into play there. The reason is I can deploy it on AWS, I can deploy it on GCP, I can deploy it on on-premise. I can use cloud to build my model, I can deploy it on on-premise. I can use on-premise to build my model and deploy it on cloud. Because the Kubernetes is acting as an hybrid cloud environment. And more and more organizations do not want to move completely into cloud. They want to have an hybrid strategy. They want on-premise plus cloud. And what I can do is I can create a Kubernetes control plane with my cloud and my on-premise, and I can have minimum running in my on-premise and use cloud for cloud busting, right? So all this is possible with Kubernetes. So from my experience, I will always stick on to Kubernetes if I have to deploy a model.
Got it. Got it. Yeah, I think I think that makes a lot of sense. I think you're right that a lot of organizations are trying to go for a hybrid thing. I think, even my organization, we're trying to think creatively about what are our short-term and long-term needs, and what kind of technologies give us the most flexibility, but also allow us speed. I do think a little bit, personally, I'm not an expert in Kubernetes. I feel like I need to, I wish David were here to really dive into you on some of the Kubernetes. I know Dimitrios knows what David is like when it comes to Kubernetes
Yeah.
stuff, but it feels a little bit like even there, while it's a beautiful piece of software with a lot of capability, there's a lot of knowledge out there, which can be a little bit overwhelming in terms of where to get started and everything. I don't know if you felt similarly when you started with it, or what your perspective on that is.
So I have an 1 hour video on Kubernetes for data scientist and data engineer. See, the one good part
Okay.
about Kubernetes, it is pretty easy to work on once you get used to it. It is nothing but a bunch of descriptor files that you need to really build, right? So that's why I created that, because I saw a lot of data scientists were really struggling with Kubernetes, and the reason I created that Kubernetes, what is required for a data scientist or a data engineer to work on. So that's kind of a good way to start if anybody is getting into that space.
Yeah, we'll definitely plug that
So
video on the show notes, and people should check it out.
yeah, we'll put that in there. I'm wondering about this deployment piece a little bit more, and there are so many different ways to deploy. And like you mentioned, there's also these patterns. And there's a great question that came up in the community the other day on what your favorite model release strategy is. Do you do A/B testing? Are you doing the canary? Are you doing shadow? And why you're doing it? And there's a comment in here from Richard Puckett. So shout out to Richard. And he said something that I just thought it was fascinating, because he was talking about A/B testing. And one issue that he runs into a lot when doing the A/B testing with models that he's deploying is that he finds it really hard to test or get the actual business KPIs that he can compare against. And so he's saying, well, I'm curious, how do you solve the problem? For example, do you just measure the model accuracy, or are you measuring a combination of factors like accuracy, precision, recall, inference time? And then how have your experiences been with measuring the impact against the business KPIs? Because we always want to tie it back to that. So I thought that was a immensely in-depth question, and really like shows the level that he's thinking of, like, is it these business KPIs which are really adding value to the business, like, increased engagement or sales number? That's what you're really trying to do with a model. But if you're just measuring the accuracy, it could have incredible accuracy, but if it's not moving the needle at all with these business KPIs, then what is it there for? And so how do you go about doing that if you're testing, or I should say, yeah, if you're trying to do this A/B
Right.
testing?
So now when we talk about because in the deployment aspect, the A/B testing is completely different than in the development aspect of it, and whatever the KPIs that comes into play is in the model development aspect of it. The reason if you take deployment, coming back to the same example, if somebody swipes a credit card and I say it's not a fraud, I will not really know that whether it was a real fraud or not unless the customer comes and complain to me. So when I deployed the model, it's I don't have the ground truth at that time, and until the customer complies, which can be 30 days later, right? Now, when it comes to model development, I will clearly focus on the business KPIs when I'm doing multiple models and I'm doing an A/B testing. A typical example is accuracy is fine, because accuracy is not a metric for fraud detection. Only 0.2% of the entire transaction is fraud. So even if might go with accuracy, if my model predicts 99% accuracy, it's still like basically it's not catching the fraud at all, right? One of the things that we do is we go and take the model and go with business KPIs. So there are two industry standard metrics that you can see for fraud detection. And the reason I'm focusing on fraud detection is because I'm more familiar with banking. And that will be true with any industry. Just substitute your own business KPIs.
One is the fraud detection rate. Second is the transaction detection rate. So basically, how many transactions are fraud and detect is actually fraud. So when I'm doing two model comparison, I exactly know what is my transaction detection rate and fraud detection rate of each model. And now I can run a statistical test to compare which model is better, right? In model deployment, that kind of you're talking about different deployment strategies, right? Shadow deployment, canary deployment, and all. And see, the machine learning model is basically you continuously keep training it at frequent interval or when the model gets drifted, right? Now, typically, what you do in that case is you don't want to override the model that is running in production with the new model, because you don't know how your new model is performing, whether it's performing better than your existing model. So that's where you go for more kind of an champion challenger deployment or canary deployment. And what you can do is you can make a load balance between those two, like say 80% to model A, which is running in production, and 20% to new model. And I can keep monitoring it. And in this case, I'm monitoring only the metrics of the model, not the business KPI. The reason is I don't know whether what is the actual label that my model predicted and what is the ground truth, right? So what I do is I just go with the assumption that my underlying distribution, data distribution has not changed, and I just see like my model output. I just tell, okay, my model has predicted 80% right and 20% wrong. And what was my ground truth? Does it match the ground truth? What about the B model? Does it match the ground truth? And that's what we typically test when it's deployment, and doing development, it's business KPIs.
Yeah, I always wish in machine learning courses in college that they taught a lot more about annotation, labeling, and the concept of ground truth. Because in most ML classes that you see a lot of students or people take in general, they say, okay, this is why and this is the label, and assume you have the label. And it's like, wait, most times we don't have the label. We don't know the confidence in our label. We can't just assume it's a given. We need to interrogate it.
Right.
And having processes, analyzing the research. There's a lot of interesting research that I've seen, especially in the medical domain, about noisy labeling and how, when you have annotator confusion, how to help your model sort of resolve that. So I sometimes wish that, we taught that more in ML classes, because I feel like that's something I missed.
Yeah, there's a challenge as well, right? Like, see, it's not only now you may have your feature store where you are storing your model predictions as well, and you say like, okay, this particular transaction I predicted A, but the real actual ground truth was B. You need to sync up your predictions frequently so that you can retrain the model, right? Otherwise, like
Right.
you're
Right.
just working on your assumptions and you're building a model based on the predicted assumptions. So this part has to really that's why really MLOps comes into play if done right? Because
Yep.
again, like we can do MLOps just for the sake of MLOps, but doing it right, you need to capture that feedback and build that a new set of data that you can feed to the model and retrain it, and that has to be pretty robust in the places.
Absolutely. The data flywheel or the virtuous cycle. I've heard so many different names for it, but that closed loop
Right.
sort of ability is crucial for ML systems to be truly impactful. Another question I have, and this is really to tap into your background. I mean, I think Dimitris and I have really enjoyed the breadth of the technical knowledge that you have. It's really impressive. As I understand it, your background is in consulting and architecture. And as an engineer myself, I think one thing I kind of struggle with particularly ML systems is how to really, take advantage of best practices in architecture and system design, right, in the context of ML. So based on your experience, doing architecture design and sort of communicating it to multiple different stakeholders, how would you, sort of advise somebody that's just getting started that says, okay, I want to use some of the principles in this field to better communicate in my company what we're trying to do with ML systems?
Got it. Now, if you really see the architecture side of it, right, when it comes to integrating your ML models with your business process, right? Now, the architecture is no different from any software architecture. So that's where I think like, if I run ABC rules and I'm just replacing the rules with the ML model, the architecture component from integrating your data sources and everything is still going to be same most of the time. It's still a data system. it's still the same integration is in place. So it's not a lot of different when we talk about architecture. So if you are a data architect, it's pretty easy to get into the ML. And whenever I say ML architecture, there's some confusion, right? Because when I talk about architecture in ML, people think it's a deep learning architecture. So
Right,
I'm not
right.
talking about that. I'm talking about system integration and ML system design, right? But one part when it comes is your architecture becomes complex as your latency decreases, as your prediction response time decreases. So if you have a batch system, your architecture can be simple. You can run a Spark job, read it in overnight, or you can execute it. But as you go into sub millisecond response time or millisecond response time, your architecture has to be pretty robust in capturing the data, because you may have multiple hops. Each ops has to be tuned at that time. If you're talking about 20 millisecond, yeah, you may have data moving from A system to B system to C system. Every system has to be scalable, has to be performant, has to be reliable as well. So that's why the challenge comes into play. Suppose B goes down and A and C are working, still it's not going to work. So you need to have that scalability added, the failover added, and that's why the complexity really comes into play. And most of the software architecture practices are pretty relevant, or the data architecture practices are pretty relevant. But you kind of have to wear a hat of an infrastructure engineer as well at that time, because you are data engineer. In the case of very low latency system, your infrastructure knowledge has to come into play as well. What is the right memory management I need to do? What is the right deployment method I need to do? What is the right CPU course I want? Everything matters at that time. So that's what I have seen implementing this system, because you learn a lot. You at the same time, the complexity also increases, and you work with multiple teams in this process to learn it.
I think that's fascinating. This idea of the architecture is going to become more complex when you need to really get the latency down, and you need to squeeze as much out of it as you
Exactly.
can, and you have all of these different systems that are working together. They all need to be tuned and finely integrated, and I really like that visual of it. It breaks it down so simply for me that I understand it very easily.
And
So
it
thank you
also
for that.
matters, right? You have the asynchronous and synchronous, right? Suppose you are depending on multiple systems, and multiple system can run in parallel. Can your call be asynchronous or synchronous? So all these frameworks makes it pretty complex to make it work. Because if I do synchronous, then I'm waiting for the response of each system to come in. Rather, I just push everything to multiple system, wait, collect everything, and send it across. Your speed increases based on your the way you envision your architecture.
Well, it's also interesting that you mentioned that for you, there's no difference between the machine learning architecture and the software architecture. And it is, at the end of the day, it is software architecture. I'm wondering, because I think I've seen a video of yours where you describe the differences between the software engineering life cycle and then the machine learning life cycle, or development life cycle, sorry. And can you just highlight the differences there and how these two are, for you, it's like, yeah, okay, what you were talking about with the architecture, it's not different. But here in the development life cycle, it is different.
So now, no, when you talk about development, right? A software engineer is basically you get a set of functionality, or get a set of functional transformations that you need to do, and then you deploy it. But when you talk about ML, it's completely different. It's more experimentation. It's like you take an input, you act on the data. After software engineering, here you feed the data, you see how your model performs. So the experimentation process at the development side is completely different between software engineering and the ML system, right? That's why I call software engineering is more deterministic. You send A, you will get B. In model, it's more probabilistic. Basically, you exactly don't know what you will get. That's where the point of error and everything comes into play, how well your model performs and everything. So both at the development time, both are completely different. Both requires a complete mindset to develop. But at the deployment time and the architecture time, both kind of is similar, right? you don't have any experimentation at that. You are just focusing on integration at that time, focusing on basically deploying it for prediction and everything. And that's what software engineering does as well. You don't have any, the probabilistic nature is gone during deployment, but it's still there during the model monitoring and all. But it's more like a software artifact that you are deploying. So that's where I think like it's almost same, and in the development it's completely different.
Yeah, that makes total sense. One question that I kind of wanted to take this conversation in the direction of is trying to understand, how a little bit more on the YouTube channel itself, and who you find consuming your content, and what that experience has been like. It'd be fun to hear more about it.
Okay. So, if you take about like most of the data scientists and data engineer, right? If you kind of tell them level 1 foundations, level 2 like maybe advanced, and level 3 expert. Most of my users are basically advanced to expert. So I don't have any content for beginners. There are some part of it for beginners, but mostly I focus on. Because there are a lot of basic content available, a lot of courses available. I don't want to overcrowd that area. So my focus has always been from intermediate to experts uh, who are in the data field and want to see like how it really works in the industry. So most of my users are from that aspect of it rather than the basic aspect of it. But it's good for someone if somebody is well aware of basics and they want to transition into intermediate and advanced stuff. They can definitely use my channel, because they will get to know how to tie their learnings, how to tie their academics, how to tie their research into production.
And how are you going about creating these? Because you do lectures, I feel like it's at least once a week, sometimes twice a week, and you're having live sessions. And how are these ideas coming? And how are you going about preparing for all of this? How do you know what topics to cover?
So what I do is I kind of have a topic in mind. I have always, if you see about like MLOps, when I started, there were not really detailed content on MLOps out there at that time. So what I do is I take a topic and then I reach out to even some of the experts who are there in the industry who have worked on MLOps, and I have them come and present. At the same time, what I do is I see like what are the area of MLOps that are pretty critical. Right now, I was talking about basically you cannot do everything in MLOps at one stretch, right? You have to see like what is critical for you. For me, continuous training is not that critical, because I don't want to take the freedom out of data scientist. Once I start the continuous training, I'm telling my data scientist, okay, you have to code it this way with this function, this ops, right? I don't want to do that. So for me, the core focus area is the CI/CD part of it, the deployment part of it, the monitoring part of it. So I just pick topic from that and focus on creating content for that, rather than continuous training is important, but I will do it maybe when I get time, or in the future I will do it. But that's how I kind of prioritize what I want to do. So I have some topics in place, and then I think about what is critical, what is not critical, what can wait, and accordingly I prioritize.
Yeah, I think the continuous training point that you make is totally right. Once you add that into it's just like with CI, right? Once you have that going, it's harder to break things. It's definitely reduces the scope for experimentation, and sort of starting from scratch, if that's something that a scientist or someone wants to do.
Right.
It's a pretty big part of it. So what kind of content do you want to start to explore next? What's on your roadmap? I'm curious.
Okay. So I am working on. I've still not started it, but I'm working on IoT and Edge Analytics. So more on the predictive maintenance side of it. I already have a course on time series. A lot of these concepts are still relevant for IoT and predictive maintenance, because that's where like kind of you have time element to it in most of the cases. So that's where I'm maybe. Post June or July, I'll be focusing on more IoT, edge analytics, predictive maintenance. That's going to be the next one.
Yeah, the IoT and edge stuff. it is a very, very different
It's
paradigm than the traditional sort of cloud machine learning deployment, where you can kind of take compute for granted, you can take your environment for granted, and you can basically say anything I can do, I want to do, or I will be able to do in the cloud. That's not the case at all with Edge.
That's right.
And I find it to be much more driven by really the business constraints there. So yeah.
That is right.
That's
The
definitely.
reason is your machines, right? If you're doing an predictive maintenance on your machine will run all the fine for 5 years, and suddenly it will break like one day, right? Or it'll show like some
Yeah.
symptomatic one day. Your data is completely skewed over there, right? You have complete imbalanced data. You will have millions and millions of observation just flat, and suddenly there will be spikes. So the challenging part is modeling it and capturing it, deploying it. So that's kind of it also gives me an opportunity to learn more about it, because at that time I go and check some research paper and see what are different techniques
Mm,
available. So it's a two-way process. I learn when I teach.
Oh,
ab-
nice.
absolutely. Yeah. I think that's something we all, and that's actually what, I will say, and maybe Demetrius, you can chime in here. It's a fun part of being in the community, because so much of what we do, I like to call it real-time Stack Overflow, because so much of what's happening is, people are just posting on the MLOps questions answer channel, and the other people are answering, and, you're learning through, answering other people's questions and debugging with them. I totally agree with that mindset of learning when you teach. I feel like it's very essential to our community. And so, yeah, I guess, we've learned quite a bit from you today, Sri. Thank you so much for taking the time.
Oh, yeah.
And really, it's my head is spinning with all the technical content that I learned today. So thank you so much for making the time to come on to our show and spend some coffee time with us.
Yeah. Thank you to both of you as
Yeah,
well.
I've been
Thank you
curious.
for really having me here. Thank you. It was really interesting. The questions were pretty great and focused on what the real world scenario is, rather than more talking about the educational stuff. So that was good.
Yeah, I've been furiously typing notes this whole time. That's why I was really quiet, because it was just like, oh my God, there's so much good stuff here. And who knows, maybe this will get transformed into a blog post, because there have been so many nuggets of wisdom that you've given us today. And I really appreciate you coming and taking the time to do
Thank
this
you.
with
Thank
us.
you very much.